Hi guys, welcome to today's lesson. So today we're going to look at some rational exponents, right? So we're going to look at exponents that are rational numbers and how to then go about solving them and also simplifying them. What exactly do you need to look out for? But just tune in and stay with me so that we can take this journey through mathematics together. So, the very first question that I want you guys to think about, right? Remember, we have leading questions. If the base of an exponent is a rational number, right? Is the value of the expression always going to be rational or not? Meaning, if the base of an exponent is a rational number, so that means I have a over b all to the exponent of x, like that, right? It doesn't really have to be x as the exponent. Will the answer that I get here be a rational number or not? That's what we're going to be thinking about as we're trying to explore everything that we're going to do here. Also, is there a way to then express an irrational number as an exponent? Remember, an irrational number will be a number that is non-recurring, number that is non-terminating, right? But those are things that I'm sure you are aware of by now. So in terms of our mapping out of exponents, remember the main thing that you always need to make sure you know are the laws of exponents, which is where we are going to start. And then we're going to then go further to looking at some surds and radicals. But before that, let's just take a look at what rational exponents are all about. The keywords for this lesson will be a rational number. What is a rational number? An irrational number, and also a rational exponent. Remember, a rational number, according to the number system, is a number that can be written in the form of a over b. But an irrational number cannot be written as a over b, right? It cannot be written as a fraction. And then a rational exponent will definitely be an exponent that's a rational number. Firstly, just so that we touch base on exactly what is an exponent, this will be the number of times a number, which is the base, is multiplied by itself, right? So the n here will represent how many times are we multiplying a by itself. So if it's 2, it means I'm multiplying a by a. If it's 3, I'm multiplying a by a by a. And the a number will therefore be what we call the base. Some laws of exponents, which by now you're supposed to really be mastering. I've categorized them into 3 categories. The first category will be a multiplication one. The second category will be a division, and then the last one will be brackets, right? With the multiplication one, if I'm multiplying powers of the same base, now I'm mentioning something that you guys normally use it as to mean an exponent, right? Remember, a power is not necessarily the exponent. The power will be a to the exponent of n. So the whole thing, we call it a power. So just for this lesson, I will be busy saying this power multiplied by that power. I'm not really making reference to the exponents being multiplied together. Please do understand that. When I say power, I'm talking about the whole term that comprises of a base and an exponent. So the multiplication law says if you are multiplying powers of the same base, no matter how many powers are there, you must add your exponents. And that's one very important law that you need to know. Some people call it the product rule. It's really up to you, as long as it has to do with multiplication. The second one will then be the division one. So if I'm dividing powers of the same base, I'm supposed to then subtract the exponents, right? And you can just look at this if maybe you don't know how to memorize it. Remember, the opposite of multiplication is division. The opposite of addition is subtraction. So memorize one, and then the opposite of that will be true for the division one or for the multiplication, depending on which one you are memorizing. My third category, as I said, will be the concept of brackets. Remember, with brackets, I have a to the exponent of m raised to n. Then the rule here will be to multiply the exponents. With this, I need to just go back quickly. Please remember that adding m and n does not give you mn. These are not like terms, only when you are multiplying. So that's just one of the things that you please need to make sure you understand. Only if we are dealing with like terms can you then add them. And now if I have two terms, or one term rather, that has a multiplication in between inside a bracket and it is raised to one exponent, I then need to distribute that exponent. I normally hear people saying, if I give you a alone and I ask what the exponent is, they say there is no exponent. That's not true. There is an exponent of 1 there, because if you say there is no exponent, you kind of mean like there is 0 or there's definitely no exponent there. So it will be the same as 1 multiplied by m, which is how I got the a to the exponent of m, and then it will be b to the exponent of 1 multiplied by m, and that's how I got the b to the exponent of m. Then the last law under brackets will then be, if I have a fraction raised to 1 exponent, you will need to distribute that to the numerator and to the denominator. But the thing that I will then make sure that you please understand here is you are not distributing this to multiply the base. No, you are distributing it to multiply with the exponent. So let's use numbers so that maybe we understand what I mean. So if I have 2 over 3 to the exponent of 4, right? And then I want to know what the answer is there. This will not be equals to 2 multiplied by 4 over 3 multiplied by 4. That's not what I mean. But if you do it correctly, it means this is supposed to be 2 to the exponent of 1 multiplied by 4 over 3 to the exponent of 1 multiplied by 4. And then you can simplify that and get your answer. You can use your calculator or you can just do mental maths there. We also have what you call some definitions of exponents. We have two main definitions that you need to know. Any number raised to the exponent of 0 will forever give us 1. So mostly I like using brackets with this one, just so that I make you understand this. If I have 2x plus 5 plus y plus a, it doesn't really matter what I have inside. And outside the bracket, I have an exponent of 0. Everything that is here will just amount to 1. There is really nothing that you're going to do after that. Then the last definition will be the one about a negative exponent. Remember, one of the rules when you're doing exponents is always leave your answers in positive exponents. Now, in terms of rational exponents, these are exponents in the form of m over n, as I said in my introduction. And then I have two definitions here that you just need to look at, or rather principles. If I have a to the m over n, it is the same as the nth root of a to the exponent of m. And then the nth root of a alone will be the same as a to the exponent of 1 over n. Now, let's just quickly look at a few examples of what this is about. If I evaluate this, excuse me, the 25 here I know is going to be the same as 5 squared. You multiply this by 3 over 2, and this will be equals to 2 multiplied by 3 over 2 will be 3. Therefore, it becomes 5 to the exponent of 3, which then becomes 125. And then with this one here, this will be equals to negative 2 to the exponent of 3. And then from here, it will be 4 over 3 is equals to, if I want to simplify this 3 and that 3 will cancel out. I will be left with the 4, which will then give me a negative 2, all of it raised to 4. Because this is an even number, it means the negative goes away. So it becomes a positive answer. 2 to the 4 is therefore 16. All right, so the concept of a rational exponent, this is just the introduction of it. I'm going to show you some I can't call them complex because we can solve them together. But some interesting questions that involve exponents that are rational numbers, right? So a 1 over 3, a 2 over 3 as an exponent. How do you go about doing that? We're going to look at that just after the quick ad break. Just stretch a bit and drink some water so that when we come back, you are then ready to work with me. Stay tuned. Hi guys, welcome back from the ad break. So I hope you are refreshed a bit. Before we look at the questions, right, we're going to look at what exactly is an exponential expression that involves a rational exponent. We're just going to try and look at that quickly, and then we'll solve some questions so that we are able to see this in practicality. So let's just jump right into it. So now, an exponential expression will or may include multiplication and division of some terms. This is the easier one to do because you just need to change your basis and then you do everything that is necessary. Or it can also be addition and subtraction. This then becomes a bit complex because then your concept of cancelling, really here you need to be sure that you are doing the right thing. When it involves only multiplication and division, the main thing that you need to do is to rewrite the basis in terms of their prime numbers and then apply the laws and the definitions of exponents. So this is quite a bit easier to do than when now it has an addition and subtraction. You definitely need to make sure that you remember how to factorize, right? If you cannot factorize, please make sure that you do go back to your notes and look at exactly how do you do that, because it's really important. Now, one type of factorization under these exponential expressions will be a common factor. Remember, you look at what is common in all the terms. And if I give you, for example, 2 to the x plus 3 to the x, you can't say x is what is common, please. What is common is a term, right? So meaning this must be maybe multiplied to 2 to the x. Then I can say the 2 to the exponent of x is common, not the x. Yes, it's common because it's on both terms, but it's not a common factor. Because remember, common factor is something different. And then the other type of factorization is the difference of two squares, which you really need to make sure that you also go back to. And then lastly will be what you call a trinomial or a quadratic expression. All right, so let's look at a practical question now of what exactly does this mean, right? So with this question, it's x to the exponent of 2 over 3 minus x to the exponent of 1 over 3 minus 2. Now, what is important here before we can go anywhere is for you to note the following. 1, the exponent of the leading term, which is the first term, must always be twice the exponent of the middle term, so that you can then use either a trinomial method or a quadratic formula if you can use a quadratic formula. If that's not the case, then you need to look at whether is it a perfect square minus another perfect square. If yes, then it's the difference of two squares. If not, then definitely it has to be using the common factor type of factorization. So that's how you really choose which type to use. But with this one, you can already see 2 over 3 and 1 over 3. The ratio there is a 2 is to 1 ratio. So that's why we can then use a trinomial method. Also, if you cannot factorize this, I'm just going to quickly show you how you can then maybe play around with your numbers such that they allow you to be able to get into the hang of factorizing this. So let me show you what I mean. So firstly, I will express this as x to the exponent of 1 over 3 all squared. Why am I doing this? It's because I want to show you that it is a quadratic equation. Minus x to the exponent of 1 over 3 minus 2, right? Now, some people prefer saying things like let x to the exponent of 1 over 3 equal to k. That means I will then have k squared minus k minus 2. Now you can already see this is our normal standard equation that or a quadratic equation that we can use, right, or factorize. So that means it is going to be k minus 2 into k plus 1, right? So that's what it will be. But remember what k is. K is the x to the exponent of 1 over 3. Then this is minus 2, all multiplied by x to the exponent of 1 over 3, and then plus 1, right? And that will be what the answer is, and you will leave it there because the question just said simplify or factorize. Now, excuse me, with this thing that I have here, this you can do with part of your solution. And then at the end, you substitute back what k is. Or you can just do it as an additional thing on the side, right, where you are working out, just so that you can get used to it until you then know how to factorize these kinds of questions. Now, a quick thing that I want to show you, I'm just going to do it with this question, but with the rest, I'm not going to do it. What I mean is, if I FOIL this out, remember it needs to take us back to the original. So I'm quickly going to show you that it does take us back there. So if I multiply this with the first term there, it becomes x to the exponent of 1 over 3 plus 1 over 3, right? Then plus x to the exponent of 1 over 3 minus 2x to the exponent of 1 over 3 and then negative 2, right? So that's what you will get if you were to FOIL this out. The 1 over 3 plus 1 over 3 gives me 2 over 3, and then x to the exponent of 1 over 3 minus 2x to the exponent of 1 over 3 will definitely give me just 1x to the exponent of 1 over 3, but a negative 1, and then my negative 2 will be there. So that's just an extra step that you can add for yourself, but on the side, so that you know that you actually factorize this correctly. All right, so another type of question will be the one that involves the difference of two squares, right? So at the top, you can see that, remember that 1 over 2 is the same as me having 1 over 4 plus 1 over 4, right? And if I add these, then I will get 1 over 2. So you can then see that this is a perfect square, minus, definitely that's a perfect square, and at the bottom then there's really not much that I can do because of the plus there. So that means I can say x to the exponent of 1 over 4 multiplied by x to the exponent of 1 over 4, and that gives me x to the exponent of 1 over 2, you see. So that's really how you can try to then change your thinking there. This will therefore be equal to x to the exponent of 1 over 4 minus 1 into x to the exponent of 1 over 4 plus 1, all of this divided by x to the exponent of 1 over 4 plus 1. And then now, because I have a like term with that, then they can cancel out, but not with the minus, with the plus 1. So it's with this one with the plus, and then my answer will be the one with a minus, 1 over 4 minus 1. And there's really not much that I can do there. You can leave it as that. Therefore, with the next question that I will then do with this one is x to the exponent of 2 over 5 plus x to the exponent of 1 over 5 minus 2, all divided by x to the exponent of 1 over 5 minus 1. So the goal here will be to make sure that my numerator has a bracket that has x to the exponent of 1 over 5 minus 1, so that at the end they can then cancel out. So this means it will be x to the exponent of 1 over 5 as the first term, all squared. Why squared? Because of that 2 that I have there. Everything else I will rewrite it the same way as it is, minus 2, all of this divided by x to the exponent of 1 over 5 minus 1. And then I can factorize the numerator. If I factorize the numerator, it will then be x to the exponent of 1 over 5 in one bracket, and then x to the exponent of 1 over 5 in another bracket. Now remember, I've been saying that if this gives you a problem, the factorizing part, you can just say let the x to the exponent of 1 over 5 to be equal to k, right? This will give us k squared plus k minus 2. Then I can factorize this, which I'm sure you are familiar with. This one, it will be plus 2, and then k minus 1, like that. So it means it's x to the exponent of 1 over 5 plus 2, and x to the exponent of 1 over 5 minus 1. All of this divided by x to the exponent of 1 over 5 minus 1. So as I said, the goal is to make sure that the numerator has a term that is exactly the same as the denominator, so that they can then cross out, right? Or rather cancel out, which is normally what we say. So this will give me a final answer of x to the exponent of 1 over 5 plus 2, and that will just be my answer. There's really not much I can do from here. You can't really simplify this because they are not like terms. Then another question now has a square root as part, or a cube root rather, as part of our denominator. The first thing to do here is to get rid of that, because we don't want to have square roots or cube roots in these questions. So this will be just x to the exponent of 1 over 3 all squared minus 7x exponent of 1 over 3 minus 8. All of this divided by, so this I will need to change it, and remember from the laws that we've been looking at, to change it, it will be x to the exponent of 1 over 3 then plus 1. So again, the goal is to make sure that the numerator has a term that is exactly the same as the one on the denominator, which in this instance is x to the exponent of 1 over 3 plus 1. So again, let me just quickly do it for you so that you always on par with what we need to do. You let k to be equals to the x to the exponent of 1 over 3. This will give me k squared minus 7k and then minus 8. Then from there, I can then factorize this, which will give me k minus the 8 and then k plus 1. Right? So it means it's x to the exponent of 1 over 3 minus 8, as I said, into x to the exponent of 1 over 3 plus 1 divided by x to the exponent of 1 over 3 plus 1. So what did I say when I started the question? The goal is to make sure that the numerator has the same thing as the denominator, right? But before that, we first need to convert the denominator to be something that does not have a set, because we don't really deal with sets. It makes it a bit complex to do that. Now you can see that this bracket here is exactly the same as my denominator there, so they then cancel out. At the end, we'll then be only left with the x to the exponent of 1 over 3 minus 8. And this will then be my final answer. So just to go back to what we've done so far, remember that the exponent of the leading term is always twice the exponent of the middle term. So the first thing to do is to always show that it is twice that. By doing what? By taking out the 2 as a square root, as you've seen me do here. And then you maintain the second term as 1 over 3. Again, with this one, we needed to make sure that the set is gone and we only have rational exponents. With that, then the goal will be to make sure that our denominator is the same as one of the numerators, so that we can cancel them out. Similarly, with the previous example that we looked at, remember my denominator was x to the exponent of 1 over 5 minus 1. The goal was to make sure that my numerator has one of the terms in a bracket that is exactly the same as the denominator. If I have a plus 1 on the numerator, then it's not the same as the denominator. It must be the same terms and the same signs. And then my final answer will be what remains on the numerator. Similarly with this one, it will be what remains on the numerator. And that will be then how we solve this particular question. All right, guys, we've really been doing a lot, but for now, I want you to take a quick ad break and then just refresh a bit, but I'll be back with some more. Hi guys, welcome back from the ad break. So we are still busy with rational exponents, right? But for now, we're gonna focus greatly on the radicals and the roots and try to see what are the principles that we need to follow and what are the laws that we also need to follow there. But for now, let's just have a look at what exactly we need to do. So the keywords for this particular lesson will be we have a radical, a root, and a set, right? They more or less mean one and the same thing, but I will show you how they differ with one another, but they really mean one and the same thing. So a radical is normally written as having the nth root of a, where n is the degree. So if I have 3 there, it means it's the cube root of. If I have 4, it means it's the 4th root of. And then the radical will be, or rather the square root will be the radical sign. Lastly, the a will be the radicand. Now it's what we want to find. How do I then change it to be an exponential form or to be a certain number that I have? A root, however, refers to a number that is repeatedly multiplied by itself a certain number of times, which is n, to get another number. So if I give you r to the exponent of n is equals to a, this simply means that r is multiplied by itself n times in order to give us the value of a. A typical example will be 2 to the exponent of 3 is equals to 8. So this is 2 being multiplied by itself 3 times in order for me to get 8, right? Now I'm multiplying by 3 there. 2 multiplied by itself 3 times in order to get 8. So 2 times 2 will be 4. You multiply it by that 2, it will definitely give me 8. So that's what a root is all about. The n, you know, is an exponent, meaning it represents how many times a number is multiplied by itself. So we can write a root as a radical or as an exponent. R to the exponent of a is equals to a can be written as r is equals to the nth root of a, which can also be written as a to the exponent of 1 over n. Let's go back to that example that I gave you. 2 to the exponent of 3 is equals to 8. This can be written as 2 is equals to the cube root of 8, which is the same as me having 8 to the exponent of 1 over 3. Now, how does this lead back to 2? Remember, 8 is the same as 2 to the exponent of 3. If I multiply it by an exponent of 1 over 3, then it definitely gives me 2. That's how it links back to me having that 2 there. So exponents as well, that we call them rational, will be, remember from rational numbers, a rational number will be a number that can be written as a fraction. Now, when it becomes an exponent, it means it's an exponent that is in the form of a fraction. And to change it to be a radical, we then write it as the nth root of a to the exponent of m. Now, I've been making examples with this. Even with this one, if I have a to the exponent of, say, 2 over 3, this can be the same as a to the exponent of 2 inside the cube root, right? So that's what it really means whenever you are trying to solve this particular question. The last thing now, remember I said I was showing you how they differ with one another, a radical, a root, and a set. A set will be an irrational number in the form of square root of a. Why is this an irrational number? It's because a, number one, is not a perfect square. Number two, a must always be greater than 0. Now, I always get people wondering, why is a greater than 0? That's because you cannot have a square root of a negative number. That will then be a non-real solution. So it will be like you don't have a solution with that. So you need to make sure that it's always a positive. For it to be a set, that positive number must not be a perfect square, because square root of 4 is 2. Square root of 16 is 4. So it means square root of 2, which is not a perfect square, is a number that is a decimal, that is not recurring and non-terminating, if we're to define an irrational number. So now let's look at a few principles that have to do with this, or some laws. The very first law is having the nth root of a multiplied by the nth root of b. What is the condition here? The condition is that the two radicals that you are multiplying by must be the same radicals, right? It must be the same radicals, meaning they have the same degree. They have the same degree, because I can't multiply a square root with a cube root and I want to apply this law. There is no way that will be applicable. And if that is the case, then you can multiply what is inside the radicals if the same radicals are there, meaning they have the same degree. Also, even if you are dividing, as long as it's the same radicals with the same degree, then you can just divide what is inside those radicals and leave it as is, right? Another law that we have is if I have one radical inside another radical, you can just multiply the degrees of those two radicals that we have there. So the mth root of the eighth root of a will be the same as the m multiplied by nth root of a. So you can just multiply those degrees there. You don't need to be calling them out, but that's just how you then pronounce it if you wanted to do that. And then if you have a radical raised to an exponent, you then need to distribute the exponent inside the radical to the term that is inside there, which will then give me the mth root of a to the exponent of n. We also have what you call the like and unlike sets. What does this mean? The like sets are sets that have the same radicand, right? It's not only the radicand that must be the same, it must also be the degree. So let me also include here, because sometimes people will think if it's the cube root of 2 plus the square root of 2, and they think the radicand is there, so it means these are like sets. That's not the case. This must also have a 3 there. So it means I will add as well and say and same degree, right? So same degree of the radicand. So not only the fact that the radicand is the same, also the degree of your radical must be the same. But the unlike ones will then be the ones that do not have the same radicand. Number one, they also don't have the same degree. So like the one that I showed you at first, when it was the cube root of 2 plus the square root of 2. I can't add this. Even if my radicands are the same there, I can't add them because they don't have the same degrees there. We also have the second last thing, which is simplest set form. This simply means that if the number is not a perfect square inside the radical, you need to write it as a product of the greatest possible perfect square and any other number. And my example here is root of 18, which is the same as root of 9 times root of 2, which then ends up being 3 root of 2. The last thing is the rationalizing of the denominator. This In mathematics, guys, we don't write the denominator as a set. We don't leave that, right? So you always need to make sure that no sets are on the denominators. To do this, you simply multiply the fraction by a special kind of 1, but let me show you exactly what this means. If I have 1 over root a, I can multiply it by 1 in the form of the denominator, which is root a over root a. If you multiply these two, it gives me root a. You multiply those two, it gives me a. And that's how you then rationalize a denominator. Guys, for now, I want you to take a quick ad break. And when we come back, we'll then do some more practice of all these laws that we've done thus far. Please stay tuned. Hi guys, welcome back from the ad break. So we are now on our last segment of the show. Here we are going to look at a few questions that have to do with rationalizing, living in simplest set form, and also just looking at some sets in terms of questions, the fractions that involve some sets, and try to solve those just so that we can put everything in practical. Because remember, it's really no point for us to talk about all this theory and not apply it anywhere. But for now, let's just have a look at this together. So, remember, the question will then be simplify the following, and the statement that they will give you will be leave your answer in simplest set form. What does that mean? It means you can't leave your answer as square root of 8. No, that's not the correct thing to do. So firstly here, I will leave this as square root of 2 because I can't do anything there, plus the square root of 4 multiplied by 2, and then this will be equals to square root of 2 plus 2 square root of 2. I get the 2 from, remember, this is going to be the same as square root of 4 multiplied by square root of 2, right? And then square root of 4, you know that the answer is always 2. And 1 square root of 2 plus 2 square roots of 2 will give me 3 square roots of 2, and that will be my final answer there. And then the same thing that we need to do here is to factorize. To do that, or rather simplify, to do that, I will change this into being the square root of 25 multiplied by the square root of 2, and then plus the square root of 2 divided by the square root of 9 multiplied by the square root of 2. And this will be equals to, remember, square root of 25 is going to be 5, root 2 plus the square root of 2 divided by the square root of 9 is 3, then square root of 2, and if I want to simplify this, it's going to be 6 square root of 2 over 3 square root of 2, which will then be equals to the 6 and the 3 will divide and give me 2, and then the 2 and the 2 will divide and give me 1, and my answer will just be 2. Now, this one is quite an interesting one, right? So it's a perfect square, you can see, because of the squared, minus a perfect square because of the squared there, right? So I can always just try this firstly by saying it's going to be square root of 11 minus square root of 7, right, into square root of 11 plus square root of 7, right? But this is just for enrichment, by the way. You don't need to do this, right? I'm just showing you where it came from. And if you multiply this, it will then take you back to that. But now let's answer the question according to what you've been looking at. Remember that square root and squared normally cancel each other. So it means I will just have 11 minus this one here will then be 7, and my answer will therefore give me 11 minus 7 will then be 4, right? But even if you use this FOIL method, now that I'm busy doing this, I'm thinking about this, I'm thinking it can actually give me the answer. But let me show you what do I mean. So this can be square root of 11 multiplied by square root of 11 will just be 11. And the square root of 11 multiplied by square root of 7 will be plus the square root of 7 multiplied by 11. And then the other one will be minus the square root of 7 multiplied by 11. And then square root of 7 multiplied by square root of 7 will be negative 7. Then the middle terms, you can see they're just going to cancel out, which takes us back to 11 minus 7, which gives me the very same answer as what I have there. So that's just some interesting things just to think about of how do you then solve these questions. Here, you need to rationalize this. So they will say simplify the following. Maybe you will find that this is your final answer. But because I told you that you can't leave your answer as you said, you will then need to multiply this by 1 in the form of the denominator. So square root of 2 over square root of 2, which will then be equals to 5 square root of 2 divided by square root of 2 times square root of 2 is the same as square root of 4, which will finally be 5 square root of 2 over 2, right? And that will be the final answer there. I don't need to do anything extra to that. And then another type of question that has to do with this, you need to rationalize the denominator as well. So we multiply by 3 plus the square root of 5 over 3 plus the square root of 5. So this is a special type of rationalizing because of the denominator here. Now, someone might ask, why are we using plus instead of the minus? If you use the minus, then it means you will still have a radical on the denominator. You will still have a set, right? So I can't do that. The plus is so that I can have a difference of 2 squares. And if I have a difference of 2 squares, this is a perfect square, that's a perfect square, then it gives me no roots on the denominator. But if I use a minus, then it takes it back to having another square root, which I will have to get rid of some other way as well, which will then be a long process. So that's why I'm using a plus here. So this will be equals to 4 multiplied by 3 will give me 12, plus 4 multiplied by that will be 4 square root of 5. All of this divided by, this will be 3 squared minus the square root of 5 all squared. Remember I said it's going to be a difference of 2 squares. So at the top here, you can't really do anything. That's going to be 5. 12 plus 4 root of 5, and then at the bottom here it's going to be 9 minus 5, right? So it's going to be 9 minus 5, and then your final answer will therefore be equals to the 12 plus square root of 5, but I need my 4 before there. So this is going to be 4 square root of 5 divided by 4. And then 4 is divisible in 12. 3 times 4 is divisible there, plus square root of 5. And that will be my final answer there. Now, our last question now for today will be a very interesting one, but it's not really a difficult question to do. So what you need to look at here will then be, firstly, you get rid of the z, right? That's the main thing that I need to do. So this will be 5 to the exponent of 4x minus 2. All of this raised to 1 over 2. Then multiplied by, I must change this to a base of 5, which is 5 cubed into x plus 1. And all of this is going to be divided by 5 to the exponent of x multiplied by, this is going to be 5 squared in brackets, and inside here it will be 6x plus 3, and then I will then need to include another bracket because of the cube root, which is 1 over 3, right? And then to simplify this, I'm just going to do it on the next slide. This is going to give me 5 to the exponent of 2x minus 1 multiplied by 5 to the exponent of 3x plus 3 all over 5 to the exponent of x multiplied by 5 to the exponent of 12x plus 6, and then this is multiplied by 1 over 3. Remember that. Then lastly, it will be 5 to the exponent of 2x minus 1. I'm just going to apply the laws at the top, which is plus 3x plus 3 all over 5 to the exponent of x. Now, if I multiply this with the 12x, it gives me plus 4x. And if I multiply this with the 6, it will then give me plus 2. And then this will therefore be equals to 5 to the exponent of 5x minus 1 plus 3 will be plus 2, and then divided by 5 to the exponent of 5x plus 2, which is simply just 1. And then that's where the beauty of mathematics comes in. Now, just to summarize everything that we've looked at, guys, is remember your laws of exponents. You really need to make sure you master them, especially for rational exponents and also for your sets, because I promise you, sets can really be a problem at times if you don't really pay close attention to them. And then also always practice simplifying expressions and leaving your answers in simplest set form. So I showed you one example of a simplest set form. For example, if I have my answer as square root of 18, I can't just leave it like that. I need to simplify this and say it's square root of 9 multiplied by 2, which will give me 3 square root of 2. You see, if it's square root of 8 as the answer, I can't leave it like that as well. It will be square root of 4 multiplied by 2, only if it can be simplified. 2 square root of 2, and that will be the answer there. So you need to make sure that you do follow your laws, your definitions, and then look at also when you're applying your laws, please pay close attention to signs, because the main thing that makes you get this incorrect is the concept of signs. And also when you're removing the brackets, right, after converting and you are multiplying, don't only multiply the exponent with the first term and leave the next term, right? What do I mean by this? If maybe I have, let me just write it down for you. 5 to the exponent of 2 and then x minus 1. Always multiply it with both of them, because some people, they just say this is 5 2x minus 1. This is incorrect. Why? Because the 2 must be distributed to both of them. So even that one must also be a 2. Guys, I hope you've been enjoying this lesson as much as I have been. Remember, the maths doctor is here. If you did not understand anything, go back to everything that I said, and I promise you, you will definitely do understand all that we've done. If you still need enrichment, consult your textbooks, look at everything that has some information in mathematics, and I promise you, it will save you some good at the end of the day. Guys, from me, the maths doctor, mathematics is food for the soul. Until next time.